Hi there, this is Thomas from investmentexcel.com. Today I will demonstrate how to build a simple linear regression model where we predict the stock price and stock return based on just one explanatory variable, being the GDP growth or GDP level. Please refer to other session on how to apply multiple regression estimation of stock returns, both with and without the matrix notation. This video and the underlying Excel workbook are available on investmentexcel.com and spotify.com. Let's start by looking at the assumed time series of returns and GDP. 25 years, 25 observations, and here yearly returns and in the stock price. This is including dividends. There is no paid out dividend in this setting. The accumulated return, simply geometric accumulation downwards the time series, so minus 8.8 in total, minus 8.8 in total return over the 25 years period. The GDP, similarly calculated return year on year and accumulated, so an increase in GDP, nominal GDP of 7.3. Let's transform this into levels, both for the stock, that is the stock price, and the GDP, starting from an initial price of this stock, this arbitrary stock, unknown stock, 1000, and then it just evolves according to the return, and that is the accumulated return, and it ends down minus 8.8%. The GDP starts, we just assume 200, doesn't really matter. So for instance 200 USD, and the same fashion it accumulates to 250, corresponding to 7.3%. Now I want to build a linear regression model where the stock price is governed by the dynamics in the GDP. So the true model is on this form. So we have a Y, which is similar to textbook notation for the endogenous variable. In this case, the Y is the stock price, is equal to a constant B0, the intercept, plus B1, the slope in the equation, times X1, which is the level of the GDP, plus a disturbance and error term, which is assumed to be normally distributed and uncorrelated between the time periods. Now the idea is to fit this model from the sample, and this is really just a sample because we want to formulate a general model for the stock price. We want to formulate a model that can be used in the true world, and for that we will use one sample, which is the one that I have here. So I need to estimate the B0 and the B1, and ultimately this will give us a formula where the stock price is predicted by an estimate of B0 plus an estimate of B1 times X1, the GDP level. The disturbance will cancel out as as the expected value of the disturbance is 0. Now how do we estimate the sample to this model? The way that we do it is to use the ordinary least squares technique, which is a technique that tries to minimize the distance between the actual value and then some predicted value given by a linear relationship in this model. So we need the model to, for each observation, minimize the distance here by changing the input values, the two estimates, two parameter estimates. So let's start by taking this. The model estimation is, and I will just type in some arbitrary values to see that there is some action here. So the model is the intercept plus the GDP slope, the beta 1, and we have to fix that and times that with the GDP level. So this is the model value given the current values of the estimates. Now, in order to minimize the distance between actual and model, we will take the actual value minus the model value and square it. Otherwise, we will get an underestimation of the total errors. So the errors that I sum now are the squared residuals. And this is the whole idea by the OLS technique, not just in the simple regression but also in the multiple regression, that we minimize the squared residuals, the sum of the squared residuals. And the way we do that is by changing the parameters. And if we find a solution that minimizes this, then it should be the best fit. So the OLS technique is basically a fitting. It's a fitting tool. It's not directly a statistical tool, it's a fitting tool. Statistics can be applied afterwards. But let's see what happens to the estimates when we use the solver. Okay, minimize the sum of squared residuals by changing the intercept and the GDP, and this should be it. Yes, very nice. Try again. Okay, and here we go. So we have the model here. I'll just get rid of this, it looks awful. So I need to do this and this, otherwise it cannot work. So this is the minimized value, and these are the parameters. And if we look at Excel's own calculation, Excel's own option where you can fit in this case an XY diagram. This is Excel's own interpolation. You see the values here: beta 1 2.87 and beta 0 342. So these are the correct values. And and I should write solver here and table here. And now you see the fitted model automatically takes into account the new values. So the stock price is equal to 342 plus 2.87 times the GDP. So this is a fundamental model telling how a given stock price, could be Amazon, should be priced. And then for forecasting purposes we need a forecast of the GDP, and in that way we can forecast the stock price. Here you see how the model evolves with time. The stock price is the gray one and the blue one is the model, and you see it's not a fantastic fit. We cannot see that from the calculations I have done here. You should refer to some sessions I have made on statistics and OLS. Here I just want to show you how to calculate the intercept in another way by using the Excel formulas. There is conveniently a function called the intercept, where you type in first the endogenous variable and then the exogenous variable, and we are left with the same, and you can do that with slope. There's another function called linest, gives the same result, and hopefully this gives a 2.87. And a third way to do it is by using the inbuilt regression functionalities in the data here. I will just show it because I am a little bit curious of the model's goodness of fit. Input Y, input X, and I want to see this, and we see exactly the same values of the X variable, of the intercept. And then what I wanted to see was this figure, the R squared, which is basically the correlation coefficient squared, and it tells that there is very, very low predictability of just 41%, which is way below what is a normal accepted threshold of around 80%. Alright, that's it. Thank you very much.